In our lab, we use a paraplasmic polyisopropanoid binding protein we call CJ for short to form highly porous protein crystals. These crystals act as a scaffold with a multitude of downstream applications. For instance, 2019, Biomod sought out to create a virus detecting microfluidic device that would use these crystals as a detection mechanism for an enzymatic reaction to happen inside and have a chemiluminescent glowing factor that could be seen by eye if the virus was detected. However, protein crystals are fragile once you take them out of their growing conditions. They risk dissolving and denature if the new solution varies too much in pH, temperature, or ion strength. So we use chemical crosslinkers to crosslink these crystals. We found that in the downstream application needed for the microfluidic device, these chemical crosslinkers actually disrupted the enzymatic activity needed for the device to work. So one of the solutions we came up with was to engineer the CJ protein to have a cysteine that could form a disulfide bond. As the protein crystals stack, the engineered cysteine would form a disulfide bond that stabilizes the crystal in a spiral-like pattern down the length of the crystal. The site where the cysteine was mutated to was confirmed computationally and then validated in a lab setting. The first validation was sequencing. The second validation was an Ellman's assay to confirm the presence of reactive files. After both of those came back positive, we started growing the engineered crystals in similar conditions to those of our CJ wild type crystals and found that the engineered crystals needed some other sort of possibly oxidizing agent to encourage it to form the disulfide bonds that we were hoping to see. So we tried growing both crystals in a solution with hydrogen peroxide, which is a good oxidizing agent, and then testing both of them in water and seeing which one dissolved first. We did indeed see that our engineered crystal stayed stable for much longer. However, in a couple hours, that crystal would also dissolve. So future directions encourage us to find possibly other sites where we can add another disulfide bond to further stabilize the crystal. And also if certain conditions that we've tried throughout this process might actually stable our normal CJ wild type crystals without the use of a mutation.